Here's your last homework assignment over targets 12 and 13 of our Unit 5. So these two targets I mentioned in the video for the notes are really good review over the whole unit. So if you can do these two targets successfully, then you should feel good about a majority of the unit just because there's so many different aspects of it within the steps here. So on number 1, taking a look at the graph, I'm noticing that this is a degree 4 quartic, and it has a negative leading coefficient because it's opening downward. So those are all things I'm going to be thinking about as I go through this problem. First thing it asks for are the zeros. So those are the x-intercepts, and you can see those just by looking at your graph. So you have x equals -3, x equals +3, and then also a positive and -2. X equals +2, x equals -2. So given that information, you can already write a majority of the factored form. So I'm going to write y equals, and I'm just giving myself a little bit more room. I'm going to leave a space, and I'm going to come back to that space in a second. So x plus 3, x minus 3, x minus 2, x plus 2. And I'm getting those because I'm just switching the signs from the zeros. So going from zeros to factors, just switching the signs. So the next thing I'm going to do is I'm going to use this other point on this graph, the 0, -9, and that's giving you an x and a y value. I don't know why that just a little not oriented there. So it's giving you an x and a y. So plugging in the -9 for the y, and then a 0 for all the x's. So -9 for the y. I'm going to put an a, because that's what I'm solving for, and a 0 for all the x's. So 0 plus 3, 0 minus 3, 0 minus 2, and 0 plus 2. And now I'm going to simplify. So that would be 3, -3, -2, +2. So if I multiply all those numbers together, that'd be -9 times -4, which is +36. And if I divide both sides by 36, then that's actually simplifies to -1/4. So our a value here is -1/4. That should make sense because there is a negative leading coefficient since this quartic was opening downwards. Okay, so now we're going to go ahead and move to our standard form. So in order to do that, first thing I'm going to do is just rewrite what I was just talking about. So y equals -1/4, x plus 3, x minus 3. So to go to standard form, the goal here is to get rid of all of these parentheses, which means we have to multiply everything together. It's just that we have to do this in steps. So at any step, you can multiply together 2 of the factors. So I'm going to choose to multiply the first 2 together and the last 2. I'm going to leave this -1/4 out in front. I'll deal with that at the very end because it's an ugly number. I don't want to work with it right now. Okay, so multiplying x plus 3 and x minus 3, I get x squared minus 3x plus 3x minus 9. And then multiplying together x minus 2 and x plus 2, I get x squared plus 2x minus 2x minus 4. And so this next step, I'm not doing anything new. All I'm going to do is simplify what I was just multiplying. So for example, those 2 cancel each other out. So I'm just left with x squared minus 9. And then here, the 2x and the -2x also cancel each other out. That doesn't always happen. That's actually just the difference of squares operating. Okay, so again, our goal is to get rid of all the parentheses, but we still have 2 sets. So I'm going to go ahead and multiply these 2 together. So that would be x to the 4th minus 4x squared minus 9x squared plus 36. I'm going to go ahead and clean that up. Oop, that should be x to the 4th to start off with. And then I'm going to, actually, let's go ahead and go to your final step, because now we can actually distribute this negative 1/4, and then we have our final answer. So we have y equals, if I distribute that negative 1/4, it would be negative 1/4 x to the 4th. Then that would be plus 13/4 x squared. And you can use the decimals if you want to. I'm just using the fractions. It's easier for me. And then that would be minus 9. And that's your final answer. It should make sense. This was a quartic, and I see x to the 4th. And it has a negative leading coefficient because it's opening downwards, and I can actually see that in the equation as well. So very similar process over here on number 2, except that this is a cubic. It's a cubic that's squiggling upwards, so it should have a positive leading coefficient in the very end. So the zeros, the x-intercepts, x equals 2, x equals, that's 5, 1, 2, 3, 4, 5, yep, and x equals 8. Okay, so once you're given the zeros, then you can actually go ahead and start writing your factored form. So it's going to be y equals something, we don't know what yet, I'm going to leave a space. Then switching the signs, x minus 2, x minus 5, and x minus 8. Okay, now we have to figure out what that something is. So in order to do that, we use this x and y value. And so I'm going to plug in a negative 14 for the y. And then remember, I call that value that we're searching for a. And then I'm going to replace all the x's with a positive 1. So 1 minus 2, 1 minus 5, and 1 minus 8. Now I'm going to simplify this. So that would be negative 1, negative 4, and negative 7. So if I multiply all that together, that gives me a negative 28. So negative 14 equals negative 28a. If I divide by negative 28, you can say that that's 0.5 or just 1/2. So it's a positive leading coefficient, which should make sense because this was a squiggle upwards. Even though it's a fraction, it's still positive. Make sure you put that a value in your factored form. So now we're taking this to standard form, and so in standard form you just have to multiply everything together. So I'm going to rewrite our factored form. And it doesn't matter which two factors you multiply together first, just pick 2. I'm going to leave the 1/2 out in front. So I'm multiplying these two factors together. I still have the x minus 8. I haven't multiplied that in yet. I'm just going to clean up the parentheses because these two combine to give me a negative 7x. And again, our goal is to get rid of all the parentheses here. So now I'm going to multiply these two together, leaving that 1/2 out in front still. So I'm going to distribute the x squared, so that would be x to the 3rd minus 8x squared. And now the negative 7x, so that would be negative 7x squared plus 56x. And now I'm going to distribute the 10, so plus 10x minus 80. Now I'm going to clean that up because I do have some like terms there. So x to the 3rd, and then for x squared, that would be a negative 15. X squared. For the x's, that would be 66x. And then for my final answer here, I'm going to go ahead and distribute that 1/2. So we have y equals 1/2 x to the 3rd. So positive leading coefficient, it's a cubic, that should be all good. Minus 15 halves x squared. Again, you can use the decimal if you prefer. Plus 33x minus 40 if I distribute that 1/2. All right, so a lot of double checking there, just making sure that your answer makes sense with what the original graph looked like. Okay, so taking a look at the back, we're going to do the opposite now. So I'm going to give you the equation and you're going to give me the graph. So on number 3, we're starting with a quartic with a positive leading coefficient. So ultimately this graph should be a W that's opening upwards. Just keep thinking about all of that. So in this problem, you're given the equation, but you're also given two factors, which actually gives you two zeros. X equals -3 and x equals -1. Just using our knowledge about zeros and factors. So when it says other zeros here, if you watch the notes, I actually changed that to all zeros because if this is a quartic, that means there's 4 of them. And so what I do is I just put 4 places for me to fill in, and then that gives me kind of a checklist. Once I filled all those in, I know that I found all the zeros. 2 of them were just given to me, so -3 and -1. I'm going to go ahead and fill those in. So the directions tell us to use synthetic division and factoring in order to find the other zeros, which in this case would be 2 more zeros. So we're going to start with synthetic division. I'm going to put a -3 on the outside since that was the first zero. I'm going to actually scoot that down a little bit. So -3 on the outside. And then on the inside, I'm going to put the coefficients from the problem. So that was 1x to the 4th. And then there's no x to the 3rd, so I have to put a 0 minus 10x squared plus 0x plus 9. If you don't put those zeros in as placeholders, then your synthetic division will not be correct. So drop your leading coefficient, multiply, add down, multiply, add down, multiply, add down, multiply. Oh, that's not multiplying, right? 3 times -3 is -9. And I get a remainder of 0, which I should get because -3 was given to me as one of the zeros, so it should result with a remainder of 0. Now this is a cubic, so I started with a quartic. After synthetic division one time, it's now a cubic. It knocks a degree off. What I'm looking for is a quadratic because a quadratic is factorable. So I'm going to use that second given 0. Remember, a -1 was also given. And I'm going to do a second synthetic division, but instead of going back to the original problem, I'm going to use those cubic numbers, the new numbers I got out from synthetic division, leaving the remainder behind. I'm going to do this again. So 1 times -1 is -1, add down, multiply, add down, multiply, add down. And again, you should get a remainder of 0. If you don't, then that means there's something wrong. So taking a look at our answer here. So I started with degree 4. I did synthetic division one time. I got degree 3. And now this is a degree 2 quadratic. So what that quadratic looks like is x squared minus 4x plus 3. Hopefully we can factor this to numbers that multiply to give us 3 and add to give us -4, thinking -1 and -3, which means our factors are x minus 1 and x plus 3, x minus 3, which means our missing zeros are +1 and +3. So it looks like for our zeros we have +1 and +3. I'm going to go ahead and put those on our graph. So as soon as I find a piece of information, I go ahead and put that on the graph just because I like to kind of keep that as a total of all the information we found so far. For the y-intercept, remember we plug in a 0 for x, which is actually a pretty easy process. So going back to this original problem, 0x to the 4th minus 10 times 0 squared, that's all 0, and then we have that plus 9, so it's going to be a +9. Once you find a piece of information, go ahead and put it on your graph. 0, 9 is the y-intercept. All right, end behavior. So we have some notation that goes with end behavior. Remember, if this isn't on your reference sheet for your test, please make sure that it is. You could even pause this and go ahead and do this real quick. So this notation means on the right side and on the left side, what are the ends doing? So we talked about at the beginning of this problem that this was going to be a W opening upwards because it's a quartic with a positive leading coefficient, which means both ends are pointing up. It doesn't matter if it's on the left or the right, they're both pointing up. The reason that that's helpful on your graph is because now you know that both ends are pointing up, so when we go to connect our points, we know that at the beginning and the end of the graph, it should be facing upwards. Okay, so local max and mins. Remember, these are the turning points. And so to find your turning points, I'm going to make a sideways XY chart just so I have more room. You can make it vertical if you want to. So for your x values for your turning points, you pick the x values right in between your x-intercepts. So right in between -3 and -1 is -2. Right in between -1 and +1 is 0. And right in between 1 and 3 is 2. So that's how you find the x values. Then to find the y values, you're going to go ahead and plug those into the original equation. So this is something that you're going to want to do with me, just because this can be just a little tedious. You want to make sure that this is not where you get points off. So I'm going to start by plugging in the -2. So -2 to the 4th minus 10. Make sure you're using parentheses when you do this. Plus 9. And I'm getting out -15. I've actually already plugged in a 0 because that's how I found the y-intercept, which was 9. But if you plug in a 0, you should get out a 9 again. And now when I plug in a 2, so I'm going to change all those -2's that I plugged in to +2's. So plugging that in, just taking away those negatives in my calculator, I am also getting out a -15. So I'm going to go ahead and connect these, or I'm going to go ahead and plot these points. So -2, -15. 0, 9 is already on my graph because that's the y-intercept. And then I have 2, -15. And so now I'm going to create the graph, and I'm remembering here that this should be a giant W. So starting at the top, because that's where my sorry about that, arrow is. I'm going to come down, hit the x-intercept, the turning point, x-intercept, y-intercept, x-intercept, turning point, x-intercept, and it should end upward. So you can see it's a little bit of kind of a wonky W, but definitely a W shape opening upwards. Okay, so let's take a look at our second one. So the second one is a cubic. And so if it's a cubic, that means it should be a squiggle. It should be a squiggle upwards because it's a positive leading coefficient. So again, you're given one of the factors, which means you're actually given one of the zeros. So our first step is to find all zeros. If it's a cubic, that means there should be a total of 3 of them. We are given 1, it's +2. So use the given factor, the given 0, set up your synthetic division, go ahead and go through that process. Hopefully this is kind of becoming second nature to you now. And you should get a remainder of 0. So we started with a degree 3 cubic. We did synthetic division 1 time, which means we're already at a degree 2 quadratic. So x squared plus 6x plus 8. We can go ahead and go into our factoring. So notice the difference between number 3 and number 4 is on number 3, when you're given a quartic, you have to do synthetic division twice. On number 4, when you have a cubic, you just have to do it once. So numbers that multiply to 8 and add to 6, those numbers I'm thinking are 4 and 2, which means your factors are x plus 4 and x plus 2, which means the 2 missing zeros are -4 and -2. So I'm going to go ahead and plot those. So we have -4, -2, and +2. All right, moving on to our next step, we have the y-intercept next. So if we plug in a 0 for x, going back to that original problem, 0 for x, you get the last number, so you should get a -16. I'm going to go ahead and plot that. All right. Next step is to think about the end behavior. So using your notation and start thinking about what the shape of this graph is going to look like. We kind of talked about it at the beginning of the problem. It's a cubic. It has a positive leading coefficient. So this graph is going to be a squiggle, and it's going to be a squiggle upwards. So on the right side, it's pointing upwards, but on the left side, it's pointing downwards. So that's helpful for our graph because on the right side, it should be pointing up. On the left side, it should be pointing down. All right, the last piece of information we need here is the local max and mins. These are the turning points. This is where we create an XY chart. Okay, so people always forget how to start this. Remember the x values are whatever is in between your two x-intercepts. So in between -4 and -2 is a -3. And in between -2 and +2 is 0. And then to find the y values, you just plug that in for x. So I'm going to start with a -3. If we plug in a -3 for x, I'm going back to that original problem. Remember to put parentheses around that -3. And again, I've said this several times, but you want to go ahead and do this with me so that we can make sure we get the same thing, or just pause it if you need more time. I'm getting a +5. Now I can go back through and in my calculator, wherever I had a -3, I can change that to a 0. Or if you remember, when we plugged in a 0, that's when we got the y-intercept. And the y-intercept was, I forgot what it was, -16. So either way you want to do that, if you just remember that you've already done it, or if you want to go ahead and redo it. So our points are -3, 5, and 0, -16, which I've already graphed. -3, 5. Okay, so this should be enough information to create a graph. So I'm going to start at the bottom with my arrow, and then I'm going to hit that x-intercept, go up to the turning point, that's where I turn, hit the x-intercept, I have the y-intercept and the turning point all in one down there, x-intercept and end upwards, and if you look, we do have a squiggle that's going upwards. So that should give us a pretty good idea that we've done this correctly.